Okay, so we have another problem here in our modern physics section. And this one deals a little bit with some electricity and magnetism. Basically, if you haven't taken already, it's a first year physics class, probably your second semester. And you don't need to know too much, but maybe a little bit will be helpful. If that's something you guys would like more of a series on, I can do that. But for right now, I'm going to assume you've taken Physics 1 and Physics 2. I'm going to assume that throughout the duration of this series. But I'll try to go over and explain the concepts the best I can. So we have a 4.5 volt battery that's connected to parallel plate capacitors. Illuminating the plate with the ultraviolet light causes electrons to be emitted from the plate. So if we had something like maybe this is the positive and this is the negative, and we hook this up to some sort of battery over here. Right. It's actually the negatives that move, but it doesn't really matter. So we have these parallel plates, and you'd have your E field and what have you. But the important thing to know is that with the battery, we have a 4.5 volt battery. We actually don't need to know too much. I just wanted to draw somewhat of a picture. I don't think we really need to visualize it too much. But basically, you have an electron. I guess it starts at the positive. Is emitted near the center, of the negative. So it'd be on the plate, but right there. And travels perpendicular towards the opposite plate. Find the speed of the electron when they reach the positive plate. So if it moved over here. And then for B, we're going to assume that the electron's emitted perpendicular to the positive plate, and then to find the speed they find, basically going the other way around. Okay, so we'll start with part A, obviously. Now, the first thing we should look at here is the kinetic energy initially. And that's just going to be 1/2 mv initial squared. Right? That's our kind of main equation here. Some important things to note, or at least one important thing to note, is the mass of an electron. It doesn't give us that in text, but you can look it up. And the mass of an electron is equal to about 9.11 times 10 to the negative 31st kilograms. So that's obviously important. And then the speed it actually gave us right here. So that's pretty easy. If we were to plug this into a calculator, which you're welcome to do, you should get about 14.1 times 10 to the negative 19 joules. So this is the amount of kinetic energy that's initially present. Now, an important equation to know is dealing with potential energy. And the important thing to know is that delta U is equal to, and this is the difference of potential, is equal to Q times delta V. And V is the potential difference of the voltage, which in this case was given to us. Delta U will be your potential energy, and delta V is your potential difference, and Q is the charge in an electron, which I'll denote that. The charge for an electron is just negative 1.602 times 10 to the negative 19 coulombs. So that doesn't change. And delta V, which is a vector, that's your potential difference. So your potential difference in this case is going to be what? Well, you're going from the negative, we're going from the negative plate and going to the positive plate. So when you go from negative to positive for the electron, you're getting higher potential. So in that case, it'll be positive 4.15 volts. Now, when we flip it, you'll see that it'll be a negative. And the way to remember it is the electron will have, the closer you get to this positive plate, you're going to have more potential energy because of the fact that they have different signs that are going to attract each other. If we go the other way, this will be a negative. You're going to lower potential. So I just wanted to make sure that's okay. Anyways, we have those values, so we can find that our change in potential energy is going to be negative 6.7 times 10 to the negative 19 joules, if you plug all that in. Now what we can do is we can look at the law of conservation of energy. So kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. In this case, they're using U. U is potential energy, which is pretty standard. Sometimes I'll do PE, potential energy, but I'm gonna be consistent with the notation and just call it U. That's how, if you work through any problem in the textbook, they're going to use U. Kind of a weird letter for potential, but, whatever. Okay, so anyways, kinetic energy final is going to be equal to kinetic energy initial plus, and I'm going to put parentheses around here, potential energy initial minus potential energy final. Or I could factor out the negative here. And kinetic energy final is going to be kinetic energy initial minus your potential final minus your potential initial. And hopefully you see that this is just delta U, final minus initial. Okay, so what we have is that our kinetic energy final is just equal to kinetic energy initial minus our change in U, our change in potential, I should say. Well, let's see what we have. We know our change in potential, and I should make a note that this is our initial kinetic energy, and we found the initial kinetic energy. So all we have to do is plug all this stuff in to get your answer. These are all knowns. And if you were to plug those two values in, you should get 20.8 times 10 to the negative 19 joules. And that is your kinetic energy final. Now, since we want to find the speed, what we can say is kinetic energy final is equal to 1/2 the mass of the electron times the final speed squared. Okay? So what should we do here? Well, all we have to do is solve. So we have what? 2 times your kinetic energy final divided by your mass square root is equal to our final velocity. And we just solved for this, and we talked about the mass of an electron. So the final speed, if you were to plug that in, is going to be about 2.1 times 10 to the 6 meters per second. Pretty fast. So that's the final speed of the electron. Now, let's say we went for part B. Let's say we didn't. Let's say instead of doing that, we did something like this. It's basically what part B is saying. You're going from the positive and moving perpendicular to the negative plate. Well, we can follow pretty similar. Basically, it's the same idea here. We would say our kinetic energy initial is 1/2 mv initial squared. And if you work that through, you're going to get the same answer. About 14.1 times 10 to the negative 19 joules. If you put in the mass of the electron and the speed that it's traveling squared. And we still want to find the change in our potential energy. So we can still use delta U equals Q times delta V. But here, we're going further away from our positive charges. So that attraction is going to be less and less. And instead of V being positive, our change in potential is going to be negative 4.15 volts. So now, if we were to plug this in, this will just change the sign. So now it's going to be 6.7 times 10 to the negative 19 joules. And really the big thing I just want to make sure we're okay with is why this is now negative and not positive. And it's because you're going away. An electron is negatively charged and you're going towards a negatively charged plate. Well, that's an issue because the negative charges are going to repel. So you have to you have to assist it to get there. So hopefully that kind of makes sense and why V is negative. The voltage is negative, I mean. And you can go through the same process and you'll find that your kinetic energy final is equal to kinetic energy initial minus delta U. You can work through it. It's the exact same process as before. The only difference is delta U is positive, so now we're going to actually be subtracting these guys. And if you do that, you'll get kinetic energy to be about 7.46 times 10 to the negative 19 joules, where we use this for our kinetic energy initial, and this is our delta U. And again, just like in part A, we can say kinetic energy final is equal to 1/2 mv final squared. And following the same math, V final is equal to the square root of 2 times our kinetic energy final divided by our mass. The mass of an electron, the kinetic energy we found above, times 2 square root. You should get 1.28 times 10 to the 6 meters per second. And that's how fast the particle is going to be going if instead of going from negative to positive, you're going from positive to negative. And that should make conceptual sense. If you have an electron, right, and you're moving towards a negatively charged plate, there's going to be a force slowing it down. So if you have a force, you're going to have some sort of acceleration opposing motion. So that tells us that it should be not going as fast as it would be if instead it was moving towards a positively charged plate, because that positively charged plate is going to attract the electron. So hopefully that made sense. If you haven't taken your second semester of physics, this might have been really confusing. Hopefully most of the actual equations make sense. Maybe like the delta V confused you, but hopefully not too bad. So yeah, hopefully.